are many misunderstandings about agility. So give me a little bit of time, let's say 15 minutes maximum, to build together a couple of agile reading glasses, okay? With these things in your eyes, you will read agility much better. So I try to give you a little bit fundamentals, roots of science, which support the idea of agility. One is iterative and incremental delivery, which you all know. The lean thinking, probably you are familiar with. The pull principle, which is very important and very much misunderstood or misused. And the empirical process control, which many people don't even know what it is. Okay? And we start from there. So let's try to have an understanding what is empirical process control and why it's different from what we know, which is normally called defined process control. Okay? This is what we are all familiar with. Works very well when you have to repeat all over again a certain amount of tasks to achieve a goal. Okay? How does defined process control work? You have a standardized input, call it a template, an artifact of whatever kind. You have a transformation activity which produces a standardized output. Okay? Requirement, analysis, specification. Then there is one more component to this. What do we need to successfully transform the input into the output? We need a certain set of skills, capabilities. And these capabilities are normally captured into a role description in your organization. So you say to analyze a requirement and transform it into a valid specification, we need an analyst. Okay? And then what you do, you create workflow by creating chains of input-output where you have then the requirement gets analyzed, there is a specification which gets designed, then you have a design which gets implemented, then you have the code which gets built, which gets tested, and so on. Okay, so you create flows and you try to define by actually predicting the sequence of activity which will bring you to the expected result. Right? And how do you control that process? Like we all do. We estimate the time by instantiating the workflow into a plan. We estimate how much time would it take to complete an activity. We track the time, the actual against the estimated time, and we check that the outcome of each activity is compliant with the template we define. That's what we do. And this is how we control process. There is a very little assumption that we make when we do that. Is that we know already where we are going because we have been there before. And that when we were there, we turned around and we have been able to define step by step every single activity we did to come from the original idea to our final product. How many times this is true with software development? How many of you are redoing the same requirement all over again? How many of you analyze the same requirement twice and come out with two different solutions because you learned something out of the first one? So the question is this process or way of controlling the development and the progress the right one, especially in complex environment, where we deal with variables which are completely out of our control? And this is the same question that Agile people put themselves long ago, starting from 1993, but the question is still valid today. Are we still assuming that we can predict what will happen in the future also in environment which are so complex that we don't even have a chance to know which variable are playing? For example, if I would draw a big red line on the highway A8 between here and Stuttgart, okay? And I ask you to tell me how many cars will cross that line in 1 hour time, what can you answer me?
Many.
Many. That's a good answer. It's a management answer. We need a real one. We need a real one. How many variables are in there? How many unknown? And the problem is, how many unknown that we don't even know exist are there? So what we don't know that we don't know is the worst thing. We can't control it at all. So which hour of which day, of which month, of which year are we talking about? There is a fair in Munich. There has been an accident. How can we calculate that? The best way is to adopt an empirical approach to that. Okay? Empirical processes are spread all over the place, but nobody recognizes them and gives them the right dignity. Environment, in many factories, in many universities, it works like this since ever. The point is, you don't know exactly what you need to produce, because you're innovating. If you would already know, then you're copying. That's a different thing. And in software, copying is very easy. You just do Ctrl-C, Ctrl-V, and it's done. It's not a complex problem to solve. The problem is, we know, we have a vision. We want to do something which is more or less there, but we have not yet a damn clue how it will look like. We know and we believe it's possible to solve that set of problems with something. We know we have it, but we don't know yet how it will look like, because we need to find it out. That's the complexity, okay? So how do we do that? We have to define a way from here to there. Would we make a plan? Well, we can make a plan, but we end up replanning every second day, because all the assumptions we make gets verified, hopefully, as soon as possible, because we want to reduce the risk. So the Agile approach, or better said, the empirical process control, work in this way. We cut this path into small interval of time, okay? Then we consider the time not anymore a variable, but a constant in the process. And what we measure to keep control over the process is the outcome, which is what adds value to the final product. So in the example of the car crossing the line, what we would do is to say, okay, let's assume the hour you want to measure is this evening between 7 and 8. We do go there, we draw the line, we measure how many cars pass the line in the first 6 minutes, okay? And then we can project and forecast how many cars will pass that line in the next minute. What do you think will happen in the second 6 minutes we measure? Will the same amount of cars pass the line? Very unlikely, right? Maybe more, maybe less, maybe there is an accident and none pass the line. So what we learn? We learn after 12 minutes, okay, which is 20% of our full interval, that in 12 minutes only a certain amount of cars, let's say 20, pass that line. And we keep on iterative and incrementally re-estimating and replanning so that we come as close as possible to the final result as much as we get closer to it. So it doesn't matter how I'm getting from here to there. What does matter is when I'm here, I'm able to measure how many cars pass that line. However I do it. Okay? So what I'm saying is empirical control, which is a fundamental difference from defined control. It doesn't matter which plan you are following. So when teams commit to fulfill user stories, it doesn't matter that the stories are estimated. Some people, very extreme lean developers, say that estimating is a waste because it added any value to the control of the process, because what we measure is either a story is done or is not done at the end of an iteration. That's the only thing that matters. So how do we measure our capability to deliver over time? Well, let's get started. Let's measure how many stories we do in one iteration. And let's assume that if we keep things constant, like the team remains the same, the goal for the project is the same, the backlog is managed by the same product owner, so we talk to one another and we understand how to deal with one another, and the user stories are done collaboratively. After 2, 3, 4 iterations, because we have some constant in place, we will play around with the remaining variables, uncertainty. So we try to reduce uncertainty by making assumptions which have a low risk and are verifiable in the shortest possible amount of time. This is empirical process control.